The basic principles of the Earth behaves like a large magnet, and its magnetic field is typically represented with lines, much like it is for a common magnet. So, at every point on and below the surface of the Earth, there is a level of magnetic field present. Objects made of certain materials, such as iron and steel, are affected by this field in such a way that they develop their own magnetic field, very similar to that of a magnet. By contrast, buried objects made of non-magnetic metals, such as aluminum, copper, and gold, are not affected by the Earth's magnetic field and therefore can't be located by magnetic locators. Schonstedt magnetic locators operate on the principle of detecting the difference in the magnetic field present at two sensors spaced a fixed distance apart. In the absence of a buried object, the field at both sensors is the same. The presence of an object made of iron or steel results in a difference between the magnetic field at the top and the bottom sensors. That difference is called a gradient. Schonstedt locators indicate the detection of a gradient to the user by changing the pitch of an audio tone and, depending on the model, with a bar graph on a visual display. The size of the buried object has an impact on the size of the magnetic field difference, or gradient. Likewise, the orientation of the buried object also has an effect on the size of the gradient detected. The same object oriented vertically will generally produce a larger difference. Some Schonstedt locators also indicate polarity, which can be useful in determining if the target is oriented vertically or horizontally. This is accomplished by observing the polarity change at each end. The fixed spacing between the sensors determines the overall length of the locator and has an impact on the field difference detected, or the sensitivity of the locator. The further apart the sensors are, the more sensitive the locator is. Object with a magnetic locator involves approaching the object while listening to the pitch of the tone and, if applicable, watching the bar graph on the display. Once near the object, small X-pattern movements help pinpoint the exact location of the target. Volume and sensitivity can be adjusted on all Schonstedt locators to accommodate various depths and sizes of targets, as well as background noise conditions.
Evet, сега ќе ви покажеме, драги гледачи, како работи магнетометарот на Geofazma скенерот. Еве, тука е лаптопот, тука се приклучите елементи, тука е сондата, веќе ја фаќа. Мора да одиме од другата страна. Еве, тука сме. Веќе сме на 4 метра. Ево овде има едно парче. Ево го, веќе почнало да го регистрирам тука. Ево го. Одиме се зголемува звукот. Ова е на 1 метро, метар и пол, 2, 2 и пол, 3, 3 и пол, 4. До овде, точно до овде, 4 метра го разпознава. Това е магнетометърът на Geofazma Skaner от Георгелия. Ovo je тест. Сега не можем да се приближам, го фаќа и мобилниот. Това е тоа. Prijetno. Sve najdobro.